In this video, I'll walk you through how we designed a global Azure-based telecom solution. We started with a few clear goals. We needed a shorter media path between two callers. We wanted something easy to implement, easy to maintain, and as cheap as possible. And it had to support failover. So if one session border controller went down, calls could automatically reroute through another path. To make that happen, we partnered with a global provider of phone numbers. They have breakout points all over the world, and we wanted our system to sit as close to those points as possible. That's where the design began. We installed session border controllers, or SBCs, near those breakout locations. The idea was simple: keep the media path short and fast. We use Microsoft Azure to deploy virtual networks around the world. Each SBC got a public IP address, firewall rules, and secure access only for Teams and our telecom partners. To handle routing and identity, we built a hub-and-spoke network. All SBCs connect back to a central hub with LDAP servers. Those servers manage routing, caller ID, and number forwarding for customers who need it. For DNS and routing, we used Azure DNS to link SBCs, Teams, and telecom providers. Everything could look up the right names and connect automatically. That was version 2 of the design, and it worked well, but we hit one problem. A global customer needed 6 separate routes inside Teams, one for each region. That was messy and hard to maintain. So we built version 3. This time, we used Azure Traffic Manager. It's basically a DNS-based load balancer. When a call comes in, Traffic Manager finds the closest SBC to the caller's breakout point. That keeps the media path short and efficient. But Traffic Manager isn't SIP aware. It doesn't understand session protocols. So we had to adjust. In Europe, where SBCs are close together, calls sometimes switch mid-session. We fixed that by changing the setup to active-passive failover. Now, if the primary SBC goes down, the secondary takes over instantly. No more call switching issues. We also built a support portal. It lets our onboarding team roll out new customers easily. They can create DNS records, run PowerShell scripts, and deploy Teams configurations in minutes. It's basically self-service onboarding. And because customers always ask, why did my call drop? Or why did the audio fail? We added a tracing tool. Support can see SIP traces, identify errors, and understand what happened fast. Then came the AI era. We integrated Azure Foundry to make support smarter. When a trace looked confusing, we sent anonymized SIP data to an AI agent. The agent analyzed it and generated 2 messages, one for the customer, written in plain language, and one for the support team, explaining what to check next or whether to escalate. That's how we turned a complex global telecom system into a fast, scalable, and intelligent Azure solution. We use Azure Log Analytic to store the CDR records, so we can make stat sites and SE the load for up to a year.